So I was at Target the other day and I found these weird cheap toys in the dollar section of Target. They were just flashing LED wands, as you can see here. It's just a simple toy, very cheap, that when you push a button it lights up LEDs in a few patterns. Right here you get your standard on, a flashing one, a slower flashing one. This one I like. And this one right here I like. A faster flash, strobe thing. And then just one that pulses the colors, and then off. Most people wouldn't look twice at this. I've passed these before and didn't really care about them because they're just cheap and they look kind of suggestive, I guess. But part of me took a little bit of curiosity out of this. I started looking at it. I bought two of them. I started looking at it in the aisle and I pushed the button and I'm like, oh, cool. So it's red, green, blue LED. So it's RGB. Then there's an LED down here too, but we're not focusing on that one. So that means that there's a controller on the inside of this wand that drives red, green, and blue LEDs. Similar to the types of controllers that you'll get with these remotes, with these IR-driven controllers right here that are used for the LED smart strips. Very similar to that, or similar to the one I made myself. So what it does is it actually controls the RGB LEDs. Now as you can see, they're not RGB in a sense, they're just standalone colors, red, green, and blue. But if they are wired in a certain way, via common cathode or common anode, you can actually use this controller to drive certain LEDs. And that's what I'm going to try to do in this video. I'm going to try to drive a 5mm RGB LED and then some LED strips with the hopes of incorporating this controller inside of an Xbox One controller later on to give it kind of a nice nice look with a bit of selectiveness. Because my old LED mod that I have on my One controller is just kind of playing off the controller's function, so I think if I add something that'll drive it, it'll be really cool. Now, I could add an AT Tiny on the inside of it and create my own patterns, just like I did with this thing right here. Or I could hack this into it, which I want to do this, because I think this would be a fun idea. So first, let's go over what a common cathode and common anode LED, RGB LED, really mean. These are very important differences that determine whether or not you can use this controller or other LEDs for certain LED remotes or drivers. For example, this RGB LED driver I made is common anode, and so are the ones that come inside the boxes. And I'll explain that right now. So there exists two types of RGB LEDs. Now an RGB LED is just an LED that consists of three colors within it. Green, blue, and red, or red, green, and blue for RGB. And you can actually create different types of colors by supplying different voltages and actually increasing or decreasing resistance and stuff like that. But these LEDs come in two different types of setups. There'll be a common cathode RGB LED and there'll be a common anode RGB LED. And these are kind of important differences to note, and I'll explain that right now. Now, an RGB LED, like I said, contains all three colors in one package. The ones on this wand actually don't have a single package, or just RGB, or RGB, however it was. So these are just single-colored LEDs, but they actually create the same signals we're looking for to achieve this mod. But I'll explain what common cathode versus common anode is right now. A common cathode RGB LED has all the colors inside of it, all the individual LEDs, but they share the same ground. So in order to turn on one of the LEDs in that case, you'd have to supply a high voltage to red, green, or blue. And for anode, it's the exact opposite. You have a shared common supply voltage, and in order to turn on an LED in that case, you have to actually ground each individual LED. So in order to turn on red, you'd have the supply voltage hooked up. All these LEDs are getting the same voltage. So with the resistance, of course, you'd want a resistor after ground in most cases. But for now, let's just keep it simple without adding resistors. So in order to turn on red, you have the positive going to each LED. In order to turn on red, all you have to do is ground the red LED, and you'll complete that circuit. Same goes for the cathode, but you're working in the opposite direction here. All LEDs share the ground source. So in order to turn on a red LED, you'd have to supply a positive voltage to the red LED with a respected resistor in series with that. Now with this wand, LED wand, we will see that there is a black glop top on top of the circuit board. That is just a cheap controller covered in epoxy to really keep the process of building this thing extremely cheap. And you'll also see 4 LEDs. Not too sure of the configuration here. Let's see if it matches. So we have red, green, and blue, and red down here, but we're not focusing on this one. We just want the red, green, and blue. But you will notice that the 3mm LEDs are single packages. They're just their own individual color. But the way they're wired is in the same configuration of a common anode RGB LED, which is what we want in order to take this thing right here and drive RGB strips, or even bigger LEDs such as a 5mm, or even a single RGB LED of this own type. But my goal here is to drive smart LEDs, RGB strips, such as basically similar to this controller right here, but a little more downsized, because this one has a lot more capabilities than this thing does. But it does have some neat patterns to it. So if you look closely, let's get a blank page for reference here. If you look closely, you will see that each LED lead shares the same positive high. We'll zoom in on that. So each LED on here, all 4 of them, share the same supply voltage, which means their colors are controlled by a ground signal, which is what we want for a common anode configuration. So now what I'm tasked with is simply just tracing all these traces back to this glop top, identifying them, and just cutting this whole thing from probably right about here, I'd say. So that way I can actually downsize this entire elongated circuit board and use it for my own means. I plan on putting this inside of an Xbox One controller to kind of give more of a light-up setup than what you would typically see in my previous one, which just used LEDs and the functions supplied by the controller to control those LEDs in a very simple way. So now what I'm going to do is actually reverse engineer all these traces and figure out what the heck's going on here, and see if I can get it to work with an RGB strip, which I think I should do just fine. So let's get started on that. After a few seconds looking at the circuit and testing it with my multimeter, I came up with a schematic, which is this guy right here. Very simple stuff, not gonna lie. I also noticed that the LEDs are flickering due to the camera. That's only in the camera. Actually, right now the LEDs are solid on, but the frame rate is actually capturing the pulse width modulation of what I guess is on the inside. So let's see if we get anything else weird happening. No, not really. It's just that solid on is what makes it look weird. Huh, cool. So like I said, I got the whole circuit condensed into this, which means I can go ahead and chop off this right here and right here. I'm actually going to try to keep, probably cut right here and cut right here, so that we can keep some of these pads to solder to, which would be really cool. But here's the circuit. Very, very simple. We have the glop top right here, the 2 top LEDs, which are red and blue, and the bottom LED, which is green. We have a switch that closes this lead coming out of the glop top to ground. That gives you the selection of colors and whatnot in the patterns. We have the ground lead. We have a lead not being used because it's going to the other LED. We don't care about that one. We also have a lead up top that's not being used. It's just not going anywhere. Actually, it's going to another LED hole, but I don't really care about that. So it's going to another LED, but I guess they cheaped out on us on that one. And we have the supply voltage in, which also goes to the LED leads themselves, the common anode configuration. So I guess it's safe to chop this board up and see if we can get it working with an RGB strip. The supply voltage for that is 12 volts DC. The voltage for this is actually 4.5, so I'm going to use a higher voltage source, but keep this at 4.5 and just control the grounds like that. Shouldn't see a problem with that, but never know. So, gonna clip right here so that way I can keep a majority of the setup here, because we have, the high voltage we can tap into off this pad right here. We actually don't need that for this, for the LED straps, but we might need it for common LEDs of bigger sizes. But if I cut it right here, I have the 2 pads on the left. Let's see, this is actually a pad going to the LED that's not there by the looks of it. Pad right on the right, which goes to the first LED, and a pad I can tap into on that LED right there. So cutting right there is not a problem. And cutting, let's see, cutting probably right here wouldn't be a problem either, because that way I have 3 pads right here which I can solder to, and also 2 pads up here, which is good. So I can actually solder the switch right here, ground that, and take a look. This one's not being used, and I can solder directly to these 2 pads right here. Well, actually only the one. Actually, I'm going to solder to 2 here because I need the supply voltage for it on that, so I can cut right there. So now we've condensed it to a very small form factor, which is really cool. All I have to do is remove these 2 LEDs, and we can get going on this. I can even, actually, I could make it a lot smaller if I want to. I can go to right at the edge of this glop top, which I might end up doing later on. But for wiring it up now to see if it works, I don't think I'm going to. I think I'm going to see how it works using the pads right there. So let's desolder those LEDs. I just got this. I have a fancy soldering station I could use, but I just got this butane powered soldering iron. Just kind of scary. Not gonna lie. Got this butane powered soldering iron right here, and I'm gonna see how well this thing works. Used it once to make a harness for my car. I'm gonna see how it works on this small stuff here. It's actually really cool. I got it from a coworker, and it's a really nice handheld soldering iron. It's not that bad for the price. It was like $5. It's butane powered, which is really nice. There's a ceramic tip on the inside, and once that element heats up, the flame actually dies down, and the ceramic element becomes hot enough to just be ignited strictly from the butane without having an actual fire, which is really cool. There's still a fire right now, and that died down, but now you can see the element heating up. And now here's where you can increase the butane flow, which also increases the temperature of the tip, which I found out the hard way is the way to do it. I lit it and just increased the butane release instantly, and the whole thing went up in flames. So you gotta be careful on that aspect. So let's see if this works. Get these 2 LEDs off. Oh, so there's one. Pads are still in good shape. Work on the other one. They're both through hole, so yeah, there you go. It's actually not that bad. So I would imagine I'd probably use this a lot outside. Especially for making stuff with my car too. That'd be really cool. So now let's get some wires soldered up to this guy and see what we can do with it. Okay, so in order to test this thing real quick, I'm actually going to use my setup here. This is the AVR driver RGB thing I made myself. I'm actually going to use parts of it to power and drive this little guy right here. This thing I made actually drives the standard RGB strips, so I'm just going to jump all the ground signals to this board, power the LEDs using the 12 volts, and power this using the 5 volts from this thing. And we should see some patterns once we push a button to ground. So let's get started wiring this guy up. I'm going to be using my soldering iron for this, and this is going to be a cut fast forward sequence. So cue that shit. Okay, so I have everything wired up. Took about, a few minutes. Didn't take long at all. So let me run through my wiring real quick. This is my custom chip right here, or circuit I made to drive RGB strips. This is the glop top. That's the strip. And these 2 things are the power supply. So what I've done is I've taken all the grounds for the LEDs and tapped them into the glop top ground for those specific colors. I might have gotten them wrong. We'll find out when I push the button. And I've also jumped the power for this. Remember, it's 4.5 volts, so I'm hoping 5 volts won't be enough. It's only be a 0.5 volt difference. We'll find out. And I've jumped the ground to it as well. So the red wire is going to the 5 volts in and the 12 volt booster. The 12 volts output is going straight to the LEDs themselves, the positive side. The grounds are being controlled through this guy right here, and the 5 volts positive will go into the USB ports. I've also got the switch right here. I don't have a button lying around right this second. So I just took a piece of copper wire and I'm just going to push it up against that contact to change the cycles and stuff. So now, let's plug it in and see what happens. Hopefully no magic smoke. I'm going to move over here. Right about here, I think we'll do it. Get my hot glue gun out of the frame. So yeah, let's plug it in and see what happens. Hopefully no magic smoke. That is a possibility. Hopefully if something does pop, it's not on my circuit I made, but here's to make another one. So as you see, the red is on for some reason. I'm not too sure why. But let's see what happens when we push a button. Get this camera scooted back a little bit. So the red is on. I'm not too sure why. Let's push a button right now. This is a blue. Okay, so there's a flash pattern right there. Let's do it again. There's the strobe flash right there. I'm not seeing any green right now. Oh, yep, there actually is a little bit of green. So there's that. The flash for that, which is pretty cool. And that right there, that's probably one of my favorite ones. The nice strobe effect. Push it again. And there we go. Flashing again. Actually, I think the red being on might be a fault within my circuit because I noticed with some of the strips that I'm running on it, red is on when the circuit should be off. So the red being on is probably something that I messed up in my circuit. I'll have to troubleshoot that and figure out why. Maybe isolate the 12 volts to figure it out. But even if the red is on, we can still work with that. We'll just have to add a transistor to ground this circuit instead of the Xbox One controller, which is not a big deal at all. So let's do this again. Let's run through the cycles. So that looks like it's off. Right there it's off. For some reason the red is on. No idea why. Well, let me turn off this light. Let's get a side-by-side. We'll put this flashing LED sexual device next to it. And we'll do a side-by-side. So right now it's off. Technically I don't know why the red's on. It's kind of bothering me, but whatever. So we'll push the button once, and we'll get that color. So with that color, we have all the LEDs lit up at once. Now with the strip, it looks a lot more intense because the LEDs are actually brighter. They operate at a higher voltage, and they're just overall going to look a lot better. So let's push it one more time. So now we got a flash. So let's push this one. We're going to do it side by side. So now we got a flash of those colors. And I should have forewarned anyone who has epilepsy, don't stare at this for too long, it might mess with your head. So now let's push the button one more time, and you will see that. And one more time over here, and you got that. So it's just basically all colors flashing at once. Looks a lot different on this because the LEDs aren't RGB, they're all separated LEDs, but on the strip it actually looks really nice. So let's do it one more time. Actually, having a bit of a trouble with my... Okay, so there's that one. So right there you have like the... I guess you could call it falling mode. It looks like the light is just falling down. So you have that. And one more time. So what do we have here? Oh, this is one of my favorites, I think. Because this really shows, this is probably one of the better patterns because it's not depending on all the LEDs at the same time. So this is probably one of my favorites, honestly. So I think pushing it one more time means off. I think. Yeah, pushing it one more time. Oh, I actually browsed through a pattern on that. Two of them. Okay, so pushing it two more times, you go through two more patterns, and then it turns off. So let's turn it on again to a fun one. So I'm going to leave it like that for a little bit, and I'm going to check on it in probably, I'll say 15 minutes, see if anything's getting hot. The glop top is really cool to the touch. Now, for this process to get inside of my Xbox One controller, you may be wondering, because it uses 12 volts power to power the LEDs. In order to do this, I'm just going to tap into my original LEDs on here. This will be a different video, by the way. So you'll have to subscribe if you want to see how that turns out. But in order to do that, I'm going to have to use a resistor for the smart LEDs, and that pulls high to 5 volts. I think it's like a 10 ohm resistor or something like that. So you can actually operate these LEDs at a lower voltage, but the strip just comes 12 volt standard. So I'm going to let that run for a little bit and see what happens. Okay, so this has been on for a few hours now, and it's still going strong. Haven't troubleshooted the red being on yet, but I'm actually going to install or wire up a 5mm RGB LED to see if the red is still on, and have fun with that. So let's get that going. This way we won't have to use a 12 volt supply for it. We'll just use the 5 coming in off of that, which will be really easy to wire up because the board has a supplied voltage on it. So yeah, let's see how that looks. I have these common anode 10mm RGB LEDs. They're diffused, and I have it soldered up to the board right there. I got the wand next to it again for comparison, so let's plug it in and see what happens. Now, previously when it was plugged in, you saw that the red LEDs were on all the time. That, I think, is a fault within my controller I made, so we'll see if that happens now. So let's kill the big light. Plug that in. There's no red light, which is really cool. It's still USB powered, so that means the fault with the red is within my circuit, not this being used as a driver. So let's turn it on. Right there we see a purpley color, a white purple color. Now the reason for this color is simple. With common cathode or anode RGB LEDs, all the color being inside one package will, or being inside of one package will actually output all the colors at once, which will give you a white purple color, unlike what you see here, which is individual LEDs, red, green, and blue. So let's push it one more time, and you see that same thing. This I believe is a flash of all, right there. So again, it's just going to be the purpley white thing. So let's do it one more time. Another flash. Looks like a slower flash. So right now we should see some versatility. We got this mode right here, so now we should see all the colors running at once. Or running at a different time, rather. So you got the red, green, blue. Let's push it again. You got that mode. Push it again, you got that one. That's a nice one, I like that one. And push it one more time. Ooh, that's a nice one too. And one more time would be off. So we have a hacked or modified children's toy RGB LED driver thing for only $1, which is really cool. Later I'm going to be putting this inside of an Xbox One controller to drive some LEDs. I think it would be really interesting to see how that would work. Actually, I might even use these 10mm ones because they're actually pretty bright. Let me get this wand out of here. Turn that thing off. They're actually really bright, just those 10mm ones. So as you can see, just using this, they're insanely bright. Again, the seizure warning is probably real right now. Let's see if I can change it. So there's a mode utilizing all the colors right there. Camera probably looks like shit. There's a fast utilization of all the colors again. Looks really weird on camera. And a slower mode using all the colors. It's a really neat one. And there we go. We're off and back onto the purple color, which I like. So this hacked child's toy became an RGB driver, which is really cool. Let me know if you like this type of video. Normally I like doing longer projects, but I also like hacking this kind of stuff just in my free time. I'm going to start recording it because I think it'll be fun to share. So let me know if you like that type of content. Leave a comment in the description below. Also subscribe because I plan on putting this instead of a rock candy controller in the future. And I just passed 600 subscribers on YouTube, which is really cool. So in celebration of that, I'm going to be giving away one of these RGB LED drivers, a brand new one. It's a 12-volt strip model thing. So all you have to do to enter that contest type thing is just leave a comment in the comment section of this video, and we'll pick one winner in about, I don't know, probably a week or two. So thanks for watching again, and subscribe. I'll see you next time.